Hello everyone, I'm Jianhong from Oregon State University. I'm one of the new postdocs. And you see I'm working on this land use and climate change with two Johns from this REACCH group. So the research questions we try to examine here is how the historical climate will affect land use and how the land use shares will change under future climate conditions. And we want to say the importance of land use change related to climate change impact assessment for the REACCH region. And when we talk about agricultural land use, we're specifically meaning that land used for crop, pasture, and forest. Since forest land is pretty stable across years, so the major land switching happens between crop and pasture. So this graph gives the conceptual framework of land use between crop and pasture, the substitute effects between this land use on the context of climate change. And to examine this, we use a fractional multinomial logical model. This model allows us to use the shares as a dependent variable and include climate variables as the explanatory variables. So the data we use for this study is the agricultural census data from 1987 to 2007 for all the counties in Pacific Northwest. We consider the climate data here. We include the precipitation and the degree days with temperature between 8 and 32 Celsius degrees. We include the climate data at both levels. One is 10-year averaged aggregated data, and another one is annual climate data, because we want to say how the aggregation may affect land use shares. And we also include some socioeconomic data like the land returns, per capita income, population density, etc. So here is part of our statistic results. From this graph, you see the blue line is crop land, the red line is pasture land. So crop land is increasing as precipitation increase or more degree days with temperature between 8 to 32 Celsius degrees. And the top two graphs shows that the climate effects, the 10-year average the climate effects on land use shares, and the bottom two shows the annual climate effects on land use shares. You see the difference with the 10-year average. Actually, it gives farmers long time to adjust the land use, but within the annual, it is very difficult, so the land use adjustment is limited. And when we use projected climate data from the recent CMI-5, we project the land use change and the future climate conditions, and you say that cropland will increase and pasture will decrease. Basically, the magnitudes of this change depending on which emission scenario we choose to run the model. And this numbers just shows the average results of across 14 GCMs and all counties in Pacific Northwest. When we look at one GCM, like the Camp ESM2 and county level, you see cropland, again, cropland is increasing and the pastureland is decreasing. And this is under RCP 45, and this is under RCP 85. So you see the major variability across counties and across GCMs. Since we have 14 GCMs, so we did kind of a sensitivity test to see the prediction power of these GCMs. And you see this is the predicted land use shares across 14 GCMs with a descending order. To see this more clearly, we calculate the mean square errors. We use a predicted within sample mean squares as the benchmark and calculate the percentage change of those GCMs mean square errors different from the benchmark, and those two columns shows the percentage change. So you could see that different GCMs actually gives different predicted outputs for our land use. And my next step is use this predict output to link with the economic model to do the economic impact assessment. So you see my question here is which model we should use and which output we should choose from. So, and also how many GCMs we should consider. So I leave this question to open discuss. Thank you.